Hello guys, today we are going to prove Einstein's equals to mc square, which is also known as mass energy equivalence. First of all, force can also be defined as the rate of change of momentum. So we write F equals to differentiating the product of mass and velocity, which is momentum, by dt, which is time. Hence we get F equals to differentiating mv by dt. According to the theory of relativity, both mass and velocity are variables. Therefore, while differentiating, we get F equals to m into dv by dt plus v into dm by dt. Now let's consider a force F displaces a body through distance dx. Then the increase in kinetic energy, which can be written as dEk, is equal to the work done, which is the product of F force into dx, the distance traveled. So dEk equals to F into distance dx. So F, we have taken out the value earlier, m into dv by dt plus v into dm by dt into dx. So by solving it, we get m dv by dt into dx plus v into dm by dt into dx. Now dx by dt, it's separated, and what is the change in distance per unit time? It's velocity, of course. So m into v into dv plus v into v, which is v square into dm. So hence we get m into v into dv plus v square into dm. Now, according to the law of variation of mass with velocity, we have m mass equals to mo, which is the rest mass, by 1 minus v square divided by c square. So now squaring on both sides, squaring on both sides, we have m square equals to mo square by 1 minus v square by c square, which is, after calculation, m square c square equals to mo square c square plus m square v square. Now differentiating both sides, we get c square 2m into dm, and I think you might know how it came. C, the velocity of light, is constant. Whether any other conditions change or not, the velocity of light, it remains same in any condition. So in another side, 0, because differentiating any constant is 0, and plus 2m into dm into v square plus 2v into dv into m square. Now solving it, we get c square into dm equals to v square into dm plus m into v into dv. So just look at v square into dm plus m into v into dv. So it is equal to the change or the increase in kinetic energy, and we took out the value earlier in this process, and so we have a new value for the increase in the kinetic energy, which is c square into dm. When a body is at rest, the velocity is 0, so the kinetic energy of the body is 0, and the mass of the body, it is MO, which is the rest mass. And when the velocity of the body becomes v, then its mass becomes m. So when the kinetic energy of the body, it increases from 0 to Ek, which is the peak value or the value at that velocity, then the mass of the body, it increases from MO to M. Hence, mass is also a variable. So we integrate both sides to get the total kinetic energy. So to get the kinetic energy, you have to integrate from 0 to Ek. Equals c square and the mass of the body, it changes from MO to M. Since the velocity of light is constant every time, it is written as it is. So Ek, or the kinetic energy, equals to c square bracket m minus mo, which is equal to mc square minus mo square. Mo c square. And when the body is at rest, internal energy of the body is Mo c square, which is also known as the rest mass energy. So when the body is at rest, it has mass Mo, and it has the rest mass energy Mo into c square, and this is known as rest mass energy. So before we calculated the kinetic energy of the body, which was mc square minus moc square. Now we are calculating the total energy of the body, which is equal to kinetic energy plus rest mass energy. So what is the kinetic energy of the body? That is mc square minus moc square. The kinetic energy of the body has been written as Ek, and we previously got the value of rest mass energy, which is moc square. Now writing the value of kinetic energy, mc square minus moc square plus moc square, which is the rest mass energy. So moc square, they cancel each other, positive and negative. So hence we get the total energy mc square. Hence we have proven the Einstein's equation E equals to mc